Okay, in this video, I'll be explaining the reassessment of the problems that I chose for the standards K1 and K2. For the standard K1, I chose the problem 1.5 in a kinematics packet. For problem K2, for the standard K2, I chose problem number 7 in the book in chapter 2, but with adding the we're adding problems such as drawing a velocity versus time graph and the position versus time graph. Okay, for 1.5, for the distance traveled, I just looked at the graph and concluded that in the first 4 seconds of his in the first 4 seconds of his movement, the player moved from 45 yard line to the 5 yard line, which makes that 40-yard travel. From the 10th second to the 19th second, the player traveled from the 5 yard line to the 50-yard line, which makes that 45 yards. So then I calculated those two distances and ended up with a result of 85 yards traveled total. So his movement, we see that he is moving in a negative. The hockey player is starting at 45-yard line and moving towards the 5 yard line in a negative direction. Afterwards, he is remaining still without moving and without acceleration for 6 seconds. And after the 6 second, in the next 9 seconds, he is moving in a positive direction with constant velocity from the 5 yard line to the 50 yard line. For the average speeds, I calculate that by calculating each individual speed for each section of his uh, if his movement, and then dividing that and then calculating the average of those speeds. Okay. For the second problem, for number 7, let me just find it. For this problem, you can pause the video to read the problem. I added, for C and D, I added the drawing of a velocity versus time graph and the position versus time graph. So in this problem, we were given the task of finding the total distance traveled and the average speed. So for the total distance travel, I realized that it is equal to the distance travel with one speed plus the difference, the distance travel with the other speed. You have the distance travel with 95 kilometers per hour, but we needed to find the distance travel for the 65 kilometers per hour. We found it that in order to calculate that, I needed to multiply the velocity, 65 kilometers per hour, times the time 2 for the 65 kilometer per hour velocity. Sorry. I figured out that since the total travel time was 4.5 hours, that is equal to t1, which is for this velocity and this travel distance, plus t2. From here, I calculated t1, which is 1.895 hours, and afterwards from this equation I calculated t2, which is equal to 2.605. Afterwards I calculated the distance traveled for this speed and this time, and this speed and this speed and this time. So I ended up with a result of 169 plus 3 kilometers per hour, which is approximately 170 which is approximately 170 kilometers per hour, and you ended up with a total distance travel of approximately 350 kilometers per hour, or exactly 349.3. So for the average speed, I use the average speed formula and definition. So it's total distance traveled over total time. So the average speed was 77.62 kilometers per hour, which is roughly around 78 kilometers per hour. I added the velocity versus time graph and the position versus time graph. So for the velocity versus time graph, I figured out my roommate just bumped into just came into the room, so I'm gonna continue. So we see that he's moving at a constant velocity for 1.895 hours, and then moving again slows down, but again moves at a constant velocity from that point onwards with a 65 kilometers per hour. As for the position versus time graph, um, he moves, like I said, with a constant velocity with one slope, but to for 1.895 hours, and afterwards moves with a slower velocity, but also constant for 2.605 hours with a different kind of slope.